All right, good morning, Dad.
Good morning, son.
All right, so we're gonna bond this together today. I spent the last week or so putting 3 coats of rolled primer on and doing some really basic body work so that I don't have to do heavy body work once it's together like this. So
And this is the tail end. This is going to be the propulsion end of the
this is the duct.
Yeah.
So these are
Is that the fan in there? That's not the fan.
the fan will go right in here.
Okay.
So this
Okay.
is the fan casing,
Okay.
and then this is the fan. This is the bulkhead.
So that's how wide the fan will be from there to the outside of the
It'll be this way,
perimeter. Yeah.
and it'll be the gap between the outside and the inside will roughly be about that.
Oh, okay. That's all the tolerance there'll be.
Yeah. So rule of thumb is you get 1% of the radius, and the radius
Oh, okay.
Radius is 12 inches.
Okay.
Nominal is a nominal two foot diameter fan, so that would give an 1/8 of an inch. We're going to try and hold between a 16th and 0.032. We're going to be trying to be half of that distance. We're going to be as close as we can be without touching down under any condition.
Cool. Good.
And then this is how the outer ducts go together. And then these are those pieces that I've been working on. And they bond onto the outside. Okay, and they bond onto the outside. Pick up these edges. And then the tail bolts into these holes here. And then these go over the top. I'll spin it. It'll be easier.
We've got a pretty good side shot there, son. Oh yeah, you want to get the. Oh, okay. Wow, that's a nice shot through there.
So this is the, I've shown this before, but this is the duct. And then this will translate in and out to about that position, about there. So this creates the minimum exit area between this radius and this radius.
And what keeps that thing centered? Is there a shaft in the middle of
There's
that?
a shaft. Okay, it's the center shaft of the entire. Stay there, Dad. I'll go get it. This is a 30mm shaft. For 30mm spindle bearings, and this will go in the middle. And this.
Are you putting any kind of lubricant on that shaft, or is it necessary?
Will be with glue-on bearings or nylon or Durlin bearings.
Okay, okay.
So they fit in here, and then we'll probably bond them in place.
Oh,
And
okay.
they'll self-lubricate. That's really all we need them to do. So it goes in like this, and then the linear actuator lives in here.
Okay.
And it just pushes against that bulkhead, from this bulkhead to that bulkhead.
Okay.
And then this is a door closure. And this one came out really good. The first one, we had to remake it, but this one came out really good, and this is like...
That's a keeper, huh?
It is a keeper. And we were thinking we're just going to leave this raw carbon, but if I'm going to leave it raw carbon, I want to book match these that pattern, but we'll see.
Okay.
Anyway, that slides in and out, goes from there. So this is the divergent configuration, where it goes in a little bit further, where we have the maximum exit area, and then it translates out. We have the minimum exit area. Somewhere in the middle of this duct is a constant area, right? And that allows us to tune. I've gone through this before, but it allows us to tune the exhaust gas velocity so that it's a better match for speed, right? And just increases the area of efficiency. That's all it's supposed to do. And my next mission, once we get all of these done, I have to make one more of these, and then I have to start the fit work for.
What do you think? Several days, I presume. Huh?
Well, we're gonna do this today. That's gonna be fine. I gotta work tomorrow. By Saturday, I'm gonna lay up some flanges. Got it dead. So I'm using the mold, and I'm gonna lay up. I have some tape in here to create for the material thickness. I'm gonna lay up a bunch of flanges. I have one around here somewhere. On one of these tables, but they have to go right here. They go right here to pick up this edge. And if I can find it, I'll show it. I do have one I made years ago.
So that's the housing that holds this in place, basically. Am I thinking right?
This is the outer fairing.
Okay.
And this lip is really important. Okay, this lip is a net drag or net thrust producer up to about 250 knots. This lip is shaped in such a way that the air accelerates all the way to the fan and will accelerate across this lip and create a low pressure zone right here at this lip, all the way to here at rest, and all the way up to about 250 knots. In that range, then it starts to hit equilibrium, and then this will start to become a net drag producer above that range. Anyway, this helps offset the low speed penalty you pay.
So it's a low speed flying characteristics of some nature, is it?
A fan of this size is optimized, and this one in particular is optimized for cruise. It's optimized for a cruise around 220 knots indicated. Below that speed, this lip will help produce thrust by creating a low pressure zone right across the front, because it's going to drag air all the way out across and accelerate it to the fan face. Now, the way this interacts with the rear of the fuselage is kind of interesting. At rest, this is sucking air from everywhere. It will literally suck air around the back. It's going to exhaust the air. I've seen this happen in the models.
Yeah.
Right. It will just, there'll be this rotation of air coming around here. In the model, I put a barrier between the two, and the power requirement. You could hear the motor load up.
Wow.
As it had to, because it couldn't suck that accelerated air.
Oh, yeah.
It was actually rotating the air. So this fan is going to suck air from everywhere at rest.
Okay.
As you accelerate and you go faster and faster, the flow lines follow the fuselage. And the fuselage is shaped in a way that it becomes more and more convergent. Okay.
Yes.
The capture area goes down. Capture area is almost infinite at rest, but because the flow lines are coming all the way across here, the capture area goes down and down and down when you need it to go down. All right. When you're going fast, you want the capture area to be a match so that you're not paying a drag penalty. The other thing that's happening is this is scavenging the rear of the fuselage. It is scavenging the air, and it is ingesting all of the wake. It's called wake ingestion, and it can increase. Are you okay, Dad?
Yeah, I didn't know what it was.
As the other skins.
Yeah.
And it can decrease the fuselage drag by a lot, like 10, 15, 20%. So there's actually a lot of subtle things going on with the position of this fan in relationship to the fuselage, how it scavenges the fuselage, and the relationship of the fuselage in terms of what it does to the inlet size, or the effective inlet size with respect to speed.
Sounds
Anyway,
yeah.
So, deal today, pull this apart, re-prep everything. It's all been prepped. And then Katie's going to come in pretty soon, and we'll spend a couple hours putting it together, and then I'm going to carefully get everything as smooth as I can. We'll let it kick. I'll do some careful sanding, and then I'll probably roll on some more primer, take it out to 400 grit, and then just do whatever minimal body work is left here.
So when that's done, this is done. This end is done.
The thing I have to do is bond these on, and that's bond these on, and then do the fit work on the outside, and then I have a completed duct. The next thing I have to do is get back into the fan itself, get all the mechanical stuff.
Make sure you get the hole in the middle.
Exactly. That's number one. Get the hole in the middle. So I'm gonna make a fixture.
Yeah.
That picks up the center hole in relationship to this. That's why I didn't drill it here.
Right.
Because it needs to be sacrosanct in the center.
Yeah.
Okay. So I'll just take a pilot hole in the middle,
Right.
and I'm gonna use my CNC to make a drill fixture that picks up that center hole.
Okay.
And then that will pick up the flange. You can stay there now. I'll get it. So this is the shaft mount. I'll be right back. Coming to you. So this is the shaft mount, and it fits on the back side of that, and it has a quarter 28 hole pattern in it. I made this years ago. I made this on a manual lathe at Northrop in the Fab Lab back when I was a technical fellow there. They had a lab that you could just go in and use. It was a courtesy.
I kind of remember that when you.
Yeah. Northrop figured that if you were willing to spend the time, they were willing to spend the money, and so they had a makerspace.
You might be able to contribute sometime. Yeah.
Right, and it would add to your skill set.
Yeah.
Right. So I was their tech fellow there. So I made this on the big machine lathe, but I might have somebody remake this for me. This one probably do, and it'll certainly do for fit. But I have to pick up this whole pattern, put it in here, and then I have to.
Is there something about it that makes you think it's not perfect?
I would like a professional machinist to make it.
Yeah.
This will certainly do, and I need. All I had was a 1-inch hole. I need to take that out to 30 millimeters. At the very least,
maybe a machinist will be able to look that over and smooth that up.
I'm going to have him fitted on a big lathe so that this is a perfect net fit.
Yeah.
And then these holes have to be drilled. Yeah. This is all going to be an adventure.
And if he can't make that one perfect, then he could make a new one.
That's right. But for fit, I'll use the one I made. Anyway, that goes in there, and then that shaft goes all the way through.
Right, and then there's something on the other end, a bearing, or the motor hooks to the motor. There's no clutch. There's no clutch device. It's straight to the motor, right?
This is just an idler, and then this thing, that shaft goes all the way through, and then this slides on it.
Oh, yeah, right. Okay, like we saw, earlier.
And then that stub comes out here. I have to drill and tap this hole, and then there's a big retaining washer. That's the washer of Jesus.
Okay.
If this fails, then it comes off. Right? There's a couple of those, and then we torque that down, and that retains.
Cool.
So that takes all the thrust, and all the other loads. There's a lot of loads in this thing, but the one we're primarily worried about is the thrust. Frankly, not that much. A fan of this size will make between 2 and 3 pounds of thrust per horsepower at rest. It's cruise optimized, and you gotta be realistic about what you want to see out of this. That's why we have to install so much power. We have to install a lot of power to overcome the deficiencies that this will have at low speeds.
Are you concerned at all about, I know you have more experience in this, but I'm just thinking about the durability of this stuff over hours of flight?
No.
Okay.
I'm
You've
not
dealt
because
with it before.
I'm not, because I've seen this over my entire lifetime.
You built drones out of this stuff, did you?
Well, yeah, and these materials are not these. There's a lot of there's 50. No, there's about. I've gone through this before, but this stuff goes all the way back to the 50s.
Yeah.
Okay, so these are not new techniques. They're not new materials. We do understand what their properties
will make
are
you wonder why
over
we
time.
don't have more
We do.
big airplanes like this.
787.
Oh, okay.
Okay.
We just don't know it. I don't.
You guys don't know it.
Yeah.
70s. It's all over all industries.
Okay.
Cars, high-end cars. It's expensive. The reason why you don't see it in your cars, it's not really applicable to a mass market product.
Okay.
It's just not. It takes too many hours.
Yeah.
Right. So it's high-end race cars.
Well, it's on my
high-end
wooden.
aerospace.
It's on my artificial leg.
Your
Yeah.
artificial
Yeah.
leg.
It's
okay?
made out of that stuff.
That's right. So it has really good properties, but it's like any other material. You got to understand what those properties are, and you have to apply it correctly. It is not a silver bullet. It is not easy, but you can make shit in a place like this that would be impossible to make any other way. And even if you could, you could make a part like this out of aluminum.
Be much heavier, wouldn't it?
The tooling necessary would be
Yeah.
unbelievable, or you'd have to form it by hand. I've seen people who are good enough in aluminum form something like this by hand.
But they're rare, skilled people, right? Basically.
Yeah. This is not an unusual thing to have on a every airliner has something
Yeah.
that looks
Yeah.
exactly
Yeah.
like this, made out of aluminum.
Right. That's true.
But a lot of them are made out of carbon.
Yeah.
A lot of them are made out of composites. So it's not. It's important to understand what's new and what's actually not new. These techniques are not new. How I'm using them, I'm pushing the boundaries of, because I've worked in it my entire life. So I'm pushing the molding of it as far as I can do to get as much in the mold as I can and not have to do secondary laminations. I really don't like having secondary laminations if I can get away with it, because you're not in control of it the way that you're in control of a vacuum bag process. Right, it's in the mold. We put a couple of addendums in. We tool in the various features that you need. You know exactly where they are. You have good references in the tools. So that's what I'm trying to do here. And so far, been pretty successful. We're hitting our weight goals.
Yeah.
But no, I don't have any. This stuff is very durable over time.
Okay.
Long Easies have been in existence for 40 years. They're not even this sophisticated. They're made with foam, fiberglass over foam, hand carved. It's a great way to make an airplane, but it's also very labor intensive, and you can't quite get these shapes. But 50 years they're still flying.
Yeah.
Okay, so no, I don't. You have to take care of it, but it's incredibly durable. Hi, Katie.
Greetings.
Greetings. Where'd you fly? Did you fly?
Not today, no. That was last week. Way too much fun last week.
Well, Dad's making a little video, and then I told him we're going to get after this, and we'll just take some video in between, because no one needs to see us mix resin and cry.
New oxygen mask for the airplane, self-donning and life support sustaining.
Very nice.
Plus, with Halloween coming up, I mean.
Very nice. Is that your actual oxygen mask? I would not put it past you.
I can think of a way. No. I just saw that and thought it was funny.
That is funny. Well, we have also mocked up to the height. I think we lost all of this last time, but we've also mocked up the height of the cockpit. This is the actual step over height, and Katie's took a splash off of it so that he can get
We have
more of the...
our top. This will be the top half that will be bolted in through the seat belts.
Right.
looking kind of Star Warsy from here.
It looks kind of 70s Star Warsy, but we kind of dig that. So
I dig it.
And then the bottom half is bolted in with the seat belts here, and then it will be upholstered all around. But once you unbolt the seat belts,
sweet. See, we like that. And then that opens up, and that opens it up so that you have access to for maintenance and for inspection.
Wow, that's pretty cool, Katie.
Yeah.
That's cool.
Yeah, so we like that.
Yeah, no, I do. I didn't realize that.
And you know what it looks like? Looks like a Battlestar Galactica.
It does, yeah.
That's what it
You know
does.
what?
It's like bad.
There's a lot of damn Star
That's
Wars
that's
in this
good.
thing.
That's
You're
good.
right.
We like that.
That's
And
the
so
reason we like it.
and so
this is our sun. Did you do the sun visor yet?
let's do it again
Okay.
because I think we lost it.
Maybe that's why when I see this stuff, I get the urge for cashews and M&Ms, you know?
So what's going on here is that glare's sunlight readability is always an issue, and iPads are in the cockpit. Period. This is just how you fly these days, and so we want to build in a little bit of infrastructure so that we can read it under any conditions, and so one of the things we thought was just to rebate it, just to push it back about an inch or two. Katie's been taking this outside and just running around the airport with it, and that helps. And then we do a sun visor in the conditions where you're just getting direct sunlight. So the two things you need to keep these iPad stuff running is something like this: keep the sunlight off of it, and then we're going to work out active cooling. We just have to do it if we want this to be a fixture of how we fly this airplane, and we really do. So we're going to work out a fan system on the back, or we're going to pick off of the HVAC system and run a cold air feed to the back of the iPad.
Are you worried about the iPad overheating at some point?
Yes.
Yes.
Yes, we are.
They do.
Yeah.
Unfortunately.
Right.
It's even in regular airplanes, it's an issue if you leave it just in the sunbeam.
Okay.
Yeah.
It's pretty
To me, it's
soft, huh?
it's a must-have. If we're going to commit to the iPad and not put something in like, a Garmin G3, then we need to deal with active cooling and sunlight
You
readability.
already know what iPads you're going to put in there, do you?
Well, this is Katie's actual flying iPad.
Yeah.
Did they make an iPad just for flying?
No, look, all
It's what you
iPads
program.
iPads are accepted by the FAA for flight.
Oh, okay.
Right.
So
Can
that's how-
you explain the whole digital flyback thing?
Yeah, they 10, 15 years ago, a company called ForeFlight came out with an electronic flight bag, which is basically all of our charts, approach plates, weight and balance, everything that we used to do with paper is now being done on iPads. And so instead of carrying, the old Pilot 75-pound Pilot case, we now carry an iPad and a backup power supply, and we're good.
Instead of Jepson charts coming to your
Yeah.
house every week that you have to update.
Update, you push a button and it updates it for you. It's awesome. I used to spend hours updating.
Yeah, it used to be the bane of the professional
Yes.
pilot's existence is
There
updating
used to be
charts.
people that made a living updating other people's charts.
Right.
So,
Totally better.
yeah, safer, better, more reliable, in all honesty.
What happens if your iPad just burns up in the cockpit? You just land normally, just
Yeah.
by visual.
We generally carry a second iPad
Oh,
and
you
a
do?
second
Okay.
power source.
Yeah, redundant. Yeah. So you'd be carrying two on any kind of flight.
Yeah.
Yeah.
Okay, so yes, there's ForeFlight, and this is how we want to fly this airplane. This is our interpretation of what we think a modern airplane should be designed around.
I like that answer, Katie. I think that's cool.
So
Yeah, I like it too. I think that's the answer, and I like that it looks like
And I like Star
Colonial
Wars.
Viper.
Yeah.
So yes,
That
so
time
this
wasn't wasted on you, Katie.
it was not, Dad. all that time in front of the TV was not wasted. So we're just still mocking all of this up. We want to use as much of this space for pilot convenience and storage as we can. But I think we have at least the elements that we want. We need to have that. We need to have the glare shield, and we need to have this inset a little bit, and then I'm almost ready to go back to the CAD with it. Okay, so this is one of those instances where we bounce from reality to CAD and back and forth. So I'll just take measurements. I'll go back into the CAD. I think I will make this whole thing. We want this to be able to tilt out so that you can stow and then tilt it back up. So there's some trickery in there, but it's going to be good, because you won't be able to do this
when the canopy's
the canopy's closed. So you need to be able to do this. Anyway, this kind of stuff is going to make the cockpit very useful. And this is one of those instances where we go back and forth from reality to CAD and back. So I'll probably do this whole thing 3D printed to begin with. We'll evaluate it once, maybe twice, and then we might be able to get away with that just being 3D printed. I could set that up and then get all the features that we need to mount the iPad in place.
Thing, use the laser to cut out.
Can do that too.
To cut out foam board, glue it together.
Yeah,
Until we have it working.
we can, and yeah, we'll do a mock-up. We'll do a mock-up off the CAD with one of the three things it does, either the laser, 3D print, or the CNC.
But we like lasers.
We like lasers, and we have a 10-watt laser.
Of course, Star Wars had a lot of them.
Yeah.
Everything.
Star Wars.
That's right.
No, it's Battlestar Galactica.
No. Cheap shot.
Oh, get
It
out.
was fun at first, but it was, yeah. And somebody pulling the doors open and shit.
Battlestar Galactica. Yeah, I know. Yeah, we just like the ships. Really,
Oh,
that's
yeah.
really
Well,
what it
I
comes
liked
down
it
to.
too. I enjoyed watching with you guys.
Yeah,
Yeah.
it was a fun show. Okay, so yeah, that's what's going to happen. We're going to bounce back and forth from CAD. We'll get a loop, and we'll just refine until we're ready to cut real stuff. Yeah, it's coming along. This is pretty much at full stop. I want to get the fan 100% done. That's my push right now. Get the fan 100% done, and then that's just one big ass subassembly off the list, and get on to the other big ass assemblies.
That's cool.
Yeah.
Goes right between the shoulder blades, you know.
That, and then the whole here.
I can't tell you how much this helps.
Difference that's going to make.
Yeah, that I sit in this on break.
Yeah. Totally.
I eat here, but I can't tell you how much this helps. Okay, and this is a Katie thing, and it becomes, you know, that's the part where you sweat, right?
Yeah, that's.
Yep. No, that makes a big difference, and we might be able to refine some of that. We might be able to pump some air through there.
Yeah.
And
In case you have bowel trouble.
all right, I think that's enough for today.
We're clean.
Yeah. Anyway, that's what's going on. It's been a couple of weeks, but you know, people's guts to work, so that's what happens.
Yeah.
All right, we're all bunny suited up. Here we go. We're gonna mix some long strand carbon into our epoxy and flux matrix, because we have a little bit more gap here than I want. It's not terrible, but it ranges between 1/8 of an inch and 1/16. The rest of these are a net bond. I'm not concerned about. We're going to just use flocks in those areas. Here we go. All right, that went reasonably well. We have it all bonded together and cleaned up best we can. We have a mixture of long strand carbon and flocks in these particular areas, and then it's just flocks in the net portions. And everything looks as good as we can hope it to look right now. I'm pleased. Glad to have this part behind me. And thanks, Katie, for hanging in there with me. See you next week.